In our first example, we're asked to use the substitution method to solve the following system of two equations and two unknowns. The way the substitution method works is that you find one variable that you can solve for in either equation, solve for it, and substitute the answer into the other equation. For example, in our second equation, it's very easy to solve for x. So let's solve the second equation for x. And again, you could solve either equation for x or y. You just want to do whatever's easiest. So solving for x in the second equation gives us that x would equal the negative 3 plus 2y. Now what we do is we take this answer and substitute it into the other equation. Since we know x has to equal negative 3 plus 2y, we can replace the x in the other equation, 5x minus 4y equals 9, with this expression. This will give us one equation only in the variable y, which we can solve with our old-fashioned methods. So let's do it. Let's replace this x with what we found to be x in the second equation. We found x to be negative 3 plus 2y. Substituting that in the other equation gives us a new equation only with y. If we solve this for y, we can take our answer and substitute it back in here and find x as well. So let's go ahead and do all that. Distributing the 5 through gives us negative 15 plus 10y minus 4y equals 9. Combining like terms on each side gives us negative 15 plus 6y equals 9. If we add 15 to both sides, we see that 6y equals 24. Dividing both sides of the equation by 6 gives us our answer for y. We find that y is going to equal 4. But remember, we're not done because our goal is to find both x and y. So now if we substitute y back into our original equation where we solve for x, we'll see that x is equal to negative 3 plus 2 times 4, which is going to be 5. So now we have our answer. We know that our answer is 5 for x and 4 for y. We can also express this as a point, since a point consists of an x-coordinate and a y-coordinate. We can say our solution is the point 5, 4. What this means is if we were to graph these two, this would be the one point where the two lines would intersect and both be true at the same time.